is a quick little video on 3D trigonometry. It's quite similar to 3D Pythagoras, so if you want to check that video out before watching this one or after watching this one. And it's similar in a way that you look for 2D triangles and use what we know before to work it out in 3D. Okay, so I'm going to go through a few examples and hopefully this will help show you a few different types of questions they could ask you. So, first example. Okay, so the A, B, C, D, E, F, G, H is a cuboid with sides of 5 centimetres, 5 centimetres and 12 centimetres. Calculate angle DFH. So we've got the cuboid, we're going to add on the lengths it's given us and draw the triangle, or draw the angle DFH and make that into a triangle. So you've got D, F and H, join those up. This is the angle you're looking for, and we've got here a right angle triangle. Okay, but we don't have enough information yet to use trigonometry on this problem. So the first step is going to be to actually use Pythagoras. You can see here we've got another triangle, and we need to find out the length here by using Pythagoras with this triangle. So our first step, so the formula a squared plus b squared equals c squared, so 5 squared plus 12 squared equals c squared, c equals square root of 5 squared plus 12 squared, so c equals 13. So we now know that this length here is 13, and now we've got two lengths and we can use trigonometry to work out that angle. So step 2, do that here. We're now looking at this right angled triangle here, which is D, F and H. Probably should have done that in orange, oh well. Okay, so we've got 5 centimetres here. This length now we've just worked out is 13 centimetres, and we're looking for this angle. I'll call that angle Y. Okay, and we're using trigonometry, so first thing to do here is Toa, I'll use trig here, so we remember. Okay, so label up hypotenuse there, adjacent and opposite. You can see here we've got opposite and adjacent, so we're using tan, so we use the formula triangle. We've got tan of y equals O over A, which equals the opposite, which is 5 centimetres over 13 centimetres, so y equals tan to the minus 1 of that, and y equals 21.0 degrees. Okay, so this is a mixture then of using Pythagoras to find out a missing length and then using trigonometry, and in that way you can work out the angle of this 3D trig problem. So the next example is going to be quite similar, again using Pythagoras and trigonometry in the problem. Okay, so the question is A, B, C, D, E, F is a triangular prism. AB equals 9 centimetres, BC equals 15 centimetres and A equals 12 centimetres. Angle ABC equals 90 degrees. M is midpoint of CD. Calculate the size of the angle between AM and BCDF. Give answer to one decimal place. Now these questions seem really wordy, giving you a lot of information, but in most cases they also give you the diagram, which is just a picture of the question, and it makes it so much easier. So I'm going to draw out the diagram that would go along to this question now. Okay, so we've got the angle we're looking for here is x, and that is the angle between AM and BCDF, so it's angle between this line and the base. So we can draw a triangle, which is here. Now I'm going to add on the size information. Okay, perfect. So we don't quite have enough information to use trigonometry straight away on this problem. Got to use Pythagoras again. And the triangle we can see here in order to work out another length on the orange triangle. So 1, and we're looking for BM, which equals the square root 15 squared plus 6 squared. So you've got the 6 squared because CM is half of CD and CD is 12 centimetres, so that's where the 6 comes from. Sort of skipped a few steps out there, but hopefully you can follow that. And that equals 16.155, etc. Okay, so step 2, we've got the size of this angle. We'll draw out the orange triangle just to make things clear. Remember, we're working with right angle triangles in these examples, and we're using trig for this orange one. Okay, so SOHCAHTOA, we've got the hypotenuse, the adjacent and the opposite. Again, similar to example 1, we've got O and A, so we're using tan formula triangle because we all love those. So tan x equals O over A, which equals 9 centimetres, 16.155 centimetres. X equals shift tan to the minus 1 of 9 over 16.155 dot dot dot. And so x equals 29.122, which equals 29.1 degrees. Yeah, the trick here, or the key here, is just looking for those triangles and thinking, have I got all the information, all the sides? If not, how can I find the side? And looking for those right angled triangles to do so using Pythag, and then finding the angle using trig. Okay, find the size of the angle AFH and the cuboid shown below. So first we need to draw out the angle AFH. H is the middle angle, so here, and well, we're working with 3D trig, so we can form that into a triangle. But unlike the other two examples, this is now no longer a right angled triangle. Okay, so there was some other information. Okay, so again here we're going to be using Pythagoras because we need the lengths of all of these sides, and the only way to get that is going to be by using 3D Pythagoras. So I'm going to go through that quickly. So try and see for yourself the different triangles we'll be using. So you can see one sort of here, another one down here, and another one is going to be here. We'll start with the bottom triangle. This is probably the easiest to see because it's on the bottom, and you've got the length AH, which is the hypotenuse here, equals the square root of 13 squared plus 9 squared. That's the square root of 250. Okay, so now AF here, again it's the hypotenuse. That's going to equal the square root of 6 squared plus 9 squared, which equals the square root of 117. And then finally, we've got FH. Again, it's the hypotenuse, and it's going to equal the square root of 6 squared, which is this one here, plus 13 squared. That's going to equal the square root of 205. If I redraw out this blue triangle. Okay, so now we're going to find the angle x using the cosine rule. So we're just going to use the formula of the cosine rule and put the values in. Okay, putting the numbers in. And then you've got to rearrange to find x. And that gives you an answer of 76.6 degrees to 1 decimal place. Okay, I'm sorry about my triangles here. Actually, I'm going to draw out the Pythagoras triangles on the side just to make that a bit clearer. Okay, so those are the triangles that I used for Pythagoras. And this is probably the most difficult type of question you'll get, because this is using the cosine rule and you have to work out 3 different Pythagoras angles. But again, as you can see, it's sort of a mix between using Pythag and trigonometry, and it's not learning anything new, you're just picking out different triangles and using 2D techniques over and over again to create 3D technique. So yeah, good luck with it all, and I hope this video has been helpful.